Hello everyone, my name is Chetna and welcome to my data world where we discuss AI, data science, analytics, and product. In this video, I wanted to talk to you about how to build reliable agents. When I say reliable, I mean in terms of the consistency of output structure. Imagine the scenario. You want to build an AI based customer interacting application and you see that every time it responds the structure of the output is completely different, right? Sometimes it gives side headings and sometimes it does not. Sometimes it gives bullet points and sometimes a list. You want to make sure that the customer experience is consistent in terms of the output that they're reading. And in this video I'm going to show you how to use the Pydantic library to structure your output in your desirable way. So let's get started. The most basic functional unit of Pydantic is the base model. A field is basically what the name says. It's a data field. You can define the kind of data type it can have and the name of the field as well. If you see here in this example, I created a user class where I have inherited the base model and my field is age. So there is a default value which you can give. You can also give a none. So it basically takes nothing. So now what I'm going to do is I'm going to create an object, the user object with no age field in it. Now let's see what happens. So you see here there is a validation error for user and it says that the field age is missing. Now let's see what happens if I give it age equals, I don't know, 10, and let's run the code and see what happens. See, it went through. It has returned nothing, which means that the validation was successful. So if you want to force a certain data field in your output, then a field is the way to go, and it's pretty straightforward. Now let's look at another type of Pydantic data form, which is literal. A literal is a little bit special. It forces the output to be within a set of values, but anything else would throw an error. Now let's see how this works. Okay, I'm going to comment out the second part, um, and let's see how the first part goes. Yeah, I have created a user class called device configuration, which can be in sleep mode, active mode, or idle. Right? It can be nothing apart from that. And I've also given another a field which is version, which is a string. And here I've initiated an instance of this class, an object basically, where I have added the mode to be active. Now, active is already in the list of values that this literal can take. So let's see what happens. See, it has printed the config which is active and version 1.2.3. Now let's see the other case. I give it a mode which doesn't exist within the list of values that the literal can take. Now let's see what happens. So I use the mode called charging. And you see there is an error. It says input should be sleep, active, or idle. So it cannot be charging, which is the input value which I've given. Right? So here, if let's say you have certain things where only yes or no, or only A, B, or C is an option, or you have stringent rules on the possible values a field can take, then you are better off using the literal. Now let's move on to another one which is called optional. Of course, as the name suggests, this makes a field optional. This is very useful when you have conditional fields. Based on certain conditions, additional fields need to be added to your output. Let's see how this goes. I'm going to show you the device config class again with two fields. One is mode, which is a string field, and version, which is the optional field. Now I've given both of them, like I've given specific values to both of them, and let's see what happens. Of course, I would expect no error, and you see that here, so it has printed the output. Now let's see what happens when I make a version truly optional, which means I don't give it a specific value. I just leave it with none, right? Let's see what happens then. So if I give a run of it, you'll see that The output is still visible to me. There was no validation error. The mode is still sleep and version is none. Now let's go on to a little more complex structure. So an optional field. Now here what happens. So you can provide a field with a specific name, and also give a default value, but you can make it an optional thing, because what this means then is this value can either be um, a particular string, or it can be nothing at all. Both of them are still valid. This is kind of similar to optional, but in field you can also give a default fallback option if nothing is available. So in this device config, I've given mode, which is an optional string. So if you see here, I've given a default as none, but then I've asked it to choose a value between sleep, active, and idle. Right? I would expect the output to be among sleep, active, or idle, but that is specifically for mode. So now let's see what happens. So I have configured two configurations, one with just the version, as you see here, the first one, and the second one with the mode defined as well. Now let's see what outputs we get for both of them. This is exactly following what we discussed. Uh, when the Pydantic validator could not find a user given value in the device config, it fell back on the default, which the field module allows you to put. So the default we've given is none, and that's what it's printing out here. But for the second one, we've given a mode and we've given a version. So both of them came out. And then the final one, which is an optional list, literal. Now this is an interesting type. This is for those situations where whether or not to give an output is optional, but in case you return an output, it has to be within a certain list of values, right? If you see here, I've given a class called survey response, where favorite color is the field. It is an optional field. When I define a list type, it is basically saying that the output can be in the form of a list, so one or more than one possible values. And literal, as you know, enforces the output to be within a specific set of values. So here I'm saying that in the survey response, you may or may not choose to respond, but if you do respond, it can be any number of values within these four values: red, blue, green, and yellow. So here I've given a few examples. Now let's look at what happens if we give a subset, which is, let's say, red and green. And then we can also look at another option where we give nothing, we just give none, and see what happens. So you see, red and green is acceptable because first, it is a list of literals, and both of the values in the list, red and green, are in the list of literals. And then optional, even if you say none, that's okay. Let's see a little bit of a negative example. Let's say there is another response which says purple. Now purple is not in this list, so let's see what happens to the third output. See, you get an error. It says input should be red, blue, green, or yellow, but we've given purple. Let's actually put this in a real life example. I'm trying to get information about a product, and pros as well as cons, along with a little bit of a summary about what the product does. This is to help customers reach a purchase decision. Now, for this use case, I'm going to use CrewAI, and the standard template for CrewAI is to define an agent, a task, an LLM, and put them all together in a crew. Right? So first, I'm going to define my LLM. I'm using Olama and DeepSeek R1, and then I move on to creating my agent. The agent is a product description summary agent. Forgive me for lack of originality. Where I gave it a goal to provide a brief summary about a product along with pros and cons. It is very open ended, I agree, but in the task, I might make it a little bit more specified. In the task, I asked it to give a summary about the product, and I also asked it to keep it under 100 words. This is just for testing purpose. I've given it an expected output, and then I've attached it to the agent. And then I have a list of products. Now, for now, I've only given one product, which is, let me show you. So it is the Aura Ring Gen 4. I actually want to make a purchase decision based on what the summary and the pros and cons look like. So for now, I'm going to use that. And then I'm going to create my crew where I define my agent, which is the product agent, the task, which I defined above. And then I'm going to do a crew kickoff, which basically triggers the agent to do its task. I've already given this a run, and this is what the output looks like. Um, yeah, it looks a little bit like a paragraph in itself, where I have to look for pros and cons. And you see here, the pros look like one very huge sentence, split from each other by commas, which makes it a little bit of a long and tedious read. um, so yeah, I think we can do better, right? And also the other thing is, if you want to, let's say, change specific parts or process specific parts of this output, you can't. You'll have to take the whole final output, do a lot of string manipulation, which again is not easy because you don't know how many words the model has written. You don't know if pros are being printed out as pros because with each run this thing can change. So that's why what I'm going to do is I'm going to create a structured output. So I'll show you what my structure looks like. I've created an object called pro, which is optional, and then a list of pros. So if the model does not find any pro, it can always return none. Same thing with cons. And then I've also created a product summary where it gives me a 50-word summary about the product. And finally, I created a compound class called summary, which is a combination of the product summary, the pros, and the cons. Everything is exactly the same except that in this version, I've asked the task to follow the output format of Pydantic structure, which is the summary class that I've created. I've also run this one and I want to show you what the output looks like. The final output looks much more structured than the previous one, which looked just like a paragraph with everything clumped together. The summary, the pros, and the cons are very well separated. And even within the pros and the cons, you can see each individual pro and con separated from the other. Now, why this is useful is that you can manipulate each part of the LLM's response. In this case, let's say you want to limit the number of pros you want, or you want to have some kind of quality control later. You cannot very easily manipulate the unstructured output from the LLM because there is no particular structure that works each and every time. So you can't do string manipulations that work for every single run of the LLM. But this will always make sure that there is a proper structure within your output. Pydantic makes it very flexible to define any kind of output format and enforce it onto the LLMs. And that was today's video. I hope you enjoyed the video today. If you did, please subscribe to my channel and like this video. Also, give your comments on what you would like me to improve, or if there's any other topic you want me to create a video on. So, see you next time. Ciao.